For 5.3, dealing with factoring. We're then going to move into solving by factoring. So we're going to take everything we do one step further. So that being said, we are going to finish up factoring today. So go ahead and do the warm-ups at the top of the page. There are 6 of them. So go ahead and do those 6 warm-ups. Hello? Hey. Hi, Pumpkin. Okay, let's go over each of those. So in that first one, you have factor 20x squared minus 24xy. So the GCF of 20 and 24 is 4. And then we take out an x, so that leaves us with 5x minus 6y. So one technique of factoring is the GCF. In number 2, the first thing we want to do is find that GCF. So in this case, 16, 24, and 40 all divide by 8. They also each all contain a y squared. So we're going to take out an 8y squared, leaving 2x minus 3z plus 5. In number 3, that is the formula for difference of squares. Difference of squares is a special type of factoring where you have a perfect square being subtracted from another perfect square. Now, in the next example, we take out a GCF of 2, and yes, it leaves behind 2 perfect squares, but that is a sum of perfect squares, and a sum of perfect squares does not factor. So you cannot factor a sum of squares. And then in that next example, that negative 64 plus 4m squared is the same as 4m squared minus 64. You can start by taking out a GCF. If you forgot your GCF, this is the answer you would have gotten. But again, that is not factored completely because 2 and 8 and 2 and 8 have that GCF, and we need to factor out that 4. You could have factored out the 4 either order. So again, these are equivalent or reflective statements. It doesn't matter the order we add. If you left it in this form but took out your GCF, you could have also had negative 4 like that. Yes?
So we could just leave it as 4 negative 16 plus m squared?
No. You have to factor the difference of squares. What I meant was that if you left it like this and did your difference of squares, then you could have had the m minus 4 and the m plus 4 in reverse order. And then last but not least, we FOILed. So FOIL again stands for first, outer, inner, last. Foiling and factoring are reverse operations of each other. So we factor the polynomial, you FOIL the binomial products. So again, here are just some hints to help you choose. When you are factoring, we look at the last term. The last term is either going to be positive or negative. If it is positive, you look at the middle term. If it is negative, then we know that the factors have different signs, whereas if it's positive, the factors will have the same signs. All right. So today we're looking at problems in which the value on x squared is greater than 1. So the problem with this technique is you can't just look at the last term. So I can't look at 6 and say, okay, what are the factors of 6 that add to 11? Because I would ignore the first part of FOIL. So what we have to do is consider the first term, which is 3x squared, as well as the last term, which is 6. So you say, okay, I need factors of 3 times 6, which is 18, that sum to my middle number. So I need two numbers that multiply to 18, but add to 11.
2 and 9.
2 and 9. So what we do is we are going to take the quadratic and we are going to turn it into a polynomial. Or basically what we're going to do is make it the FOIL line of FOIL. So we're going to turn the quadratic into the FOIL line of FOIL. And we're going to do that by replacing the 11x with 2 and 9. The order you replace it does not matter. So like even though here I have 2, 9, in my problem I can write 9, 2. I could also in my problem write 2, 9. The order does not matter. It'll work out the same either way. I will tell you a time that there is a reason you should put one first versus the other. But again, doesn't matter. So if I leave it the way it is now, what I want to do is take out the GCF. So 3 and 2 don't have a numerical GCF, but we have x squared and x. So once you have 4 terms, you are thinking factor by grouping. So when I turn it into FOIL, I'm going to factor by grouping. So I'm going to take out the x, leaving behind 3x plus 2. Over here, 9 and 6 both divide by 3, leaving behind 3x plus 2. My middle terms have a GCF once again. So 3x squared plus 11x plus 6 in factored form is 3x plus 2 times x plus 3. Now, back in the day, you guys used to do guess and check. And you would sit there and you'd say, okay, what two numbers multiply to 3x? What two numbers multiply to 6? And then you had to like sort of FOIL it to figure it out. 3x squared plus 11x plus 6 they're not bad if you use guess and check. What happens is we get to more complicated numbers where guess and check doesn't quite work as nicely, where like 3 might not be prime. I only have 2 sets of factors. So you might get to like 8 or 12 but have multiple factors, and then guess and check can become time consuming. So I call this method the reverse FOIL method. It works for all quadratics. It just eliminates guess and check. I don't force you to use this. If you like guess and check, you can do that. But if you like a formula that works always, this is it. Or a method, so to speak, that works always. I've seen it taught as tic-tac-toe. Then you gotta kind of make a board, and I don't think you see that process of reverse FOIL. So I like to see the FOIL in reverse and to show the connection between the 2 types of problems. So we have 4x squared plus 16x plus 7. So again, it's the first term and the last term. So 28, that sum to the middle term. So you need 2 numbers that multiply to 28 and add to 16. So that's 14 and 2. Again, the first term and the last term are both positive. Therefore, this is going to give me 2 positive factors. We're going to replace the 16 with 14 and 2. We're going to do factor by grouping the first 2 and grouping the last 2. We're going to take out a GCF from each of my terms. If the only GCF is a 1, like 2x plus 7, 2 and 7 only divide by 1. There's no variable either. You take out a GCF of 1. So if there's no numerical or variable aspect, it's a 1. So that when you get our 2 factored terms, it's 2x plus 7, 2x plus 1. And again, the reason for that is that 1 is kind of like the placeholder. If I were to take this GCF out, there has to be something there to multiply back in. So we have 5x squared minus 13x plus 8. Now my middle term is negative. So when your middle term is negative, that means that both factors are negative because my last number is positive. So if the middle term is negative and the last number is positive, both of my factors are negative. So I need 2 numbers that multiply to 40 and add to negative 13. And yes, the 2 numbers that replace it can be the same 2 numbers that we multiplied. Like they can be A and C. So in this case, it's negative 5 and negative 8. So a lot of times people try not to pick A and C, but it can be A and C. Now, if I'm plugging this one in and I'm replacing it, I'm going to write the 5 first because it's going to put the 5s together. And I'm going to write the 8 second because it's going to put the 8s together. This is where you have to also recall from factor by grouping that if you have a negative third value when you do your factor by grouping, the negative goes inside the parentheses and comes out as part of my GCF. So it takes out a 5x and leaves an x minus 1. This is going to take out a negative 8 and leave x minus 1. And again, you can see if you distributed that back in, you get negative 8x, positive 8. So that means in factored form, this is 5x minus 8. x minus 1. And I know I said it, so I said it's like reverse FOIL. This would be your first, outer, inner, last if you actually FOILed this answer. That's why I call it reverse FOIL. Can we see it? Okay, and then the last example is a case where you have a negative at the end and a negative in the middle. So a negative at the end and a negative in the middle means you're going to have one of each in your magic X, or one of each in our final answer, meaning that in my final answer, one is going to be negative and one is going to be positive. So 3 times negative 4 makes the top of the magic X negative 12 and the bottom negative 4. Now this is the case where the order I replace that middle term, I say kind of matters, because if you're replacing that middle term, if you write the negative number first, it makes your factor by grouping easier because you don't have to worry about pulling out a negative GCF. So what two numbers multiply to negative 12 and add to negative 4? Got it, Elijah?
Negative 6 and 2.
Perfect. So this is where I would write the negative 6 first as opposed to the positive 2, simply because when I do factor by grouping, I don't have to worry about taking out that negative GCF. And there's your final answer. So again, I like it because it is very functional. It works. There's no guessing. So go ahead, take a minute and try the bottom 4 on your own. I'll kind of walk around. That way if you're having trouble setting it up, I can help you. Because again, I think Alright, so let's quickly go over them. It looks like most of you are done. So that first one, our final answer should have been x plus 4 to x plus 3. So the factors of 24 that sum to 11 were 8 and 3. You replace the 11x with 8 and 3. Do your factor by grouping, and you get 2x plus 3, x plus 4. Okay, and B, we had 4x squared plus 7x plus 3. So it factored to be 4x plus 3, x plus 1. I feel like everybody got letter C right when I was walking around. So 2x squared minus 7x plus 6 became 2x minus 3, x minus 2. And then our last one, what? Is not there. Let's do that one real quick. So when I look at the last one, we have 3x squared minus 16x minus 12. So when you multiply 3 and 12 together, you get negative 36. And then our bottom is negative 16. So you need two numbers that multiply to negative 36 and add to negative 16, where one is going to be negative and one is going to be positive. Okay. There we go. So it's 18 and 2. Now, if you get into a problem where you have a magic X like that, and you go through or you look at all of your numbers and nothing works, that's the case where you have a prime or a not factorable.